Hi guys, this is Pablo and I'm going to be talking about IoT security. So let me flip over to my slides. All right, so we're going to be talking about how to shield an IoT product from the OWASP IoT top 10, or how the S in IoT stands for security. Okay, who am I? I'm a security professional or a hacker, trainer. I've been working in security for the last 15 to 20 years, depending on where you start counting. I worked on defense, offense, and I just enjoy doing security. In my free time, I like doing Shotokan karate and slacklining, especially right now in the summer. Okay, I work for 7 Shift, which is a company I founded around 3 years ago, and we're a boutique security company focusing on cybersecurity and IoT. Normally, we work with security testing devices, applications, mobile applications, and whatnot. When we're lucky enough to get called into the beginning of a project, we actually try to help our customers implement security by design. We help them with certification to achieve security certifications and whatnot, automation, and then we do trainings, public trainings at least twice a year, normally in May and November. More or less, and we do trainings on IoT. We have 2 hands-on trainings, which are these 2, the IT Security Bootcamp and Assessing and Exploiting Control Systems and IIoT. We need a new name for that, it's just too long. But these are hands-on trainings where you will be hacking on devices, PLCs, wireless hacking, hardware hacking, and we have a training that is more for your theoretical part, where we talk about security strategy, threat modeling, and whatnot. So we're going to be running them this year live and online because of the same reason we're doing this conference online, the Corona. But just take a look at our website and see if there's something for you there. Okay, enough for the plugs and about me. Let's go down to content. What I'm going to be talking about today. First of all, I'm going to be talking about an introduction to IoT, what it is, a little bit of the architecture. Then I'm going to go into IoT security, what we see that the current status is, and talking about the attack surface. Then we're going to quick jump into the OWASP IoT top 10. I'm going to show you a list, and then I'm going to try to go through a couple of examples of the GPS trackers and smart cities to put this all into practice. So IoT, I think everybody knows what it is. It stands for the Internet of Things. And basically you have objects that are interconnected, let's say networked in some way, and they have interactions with the physical world through sensors and actors. Okay? And some of the devices have both, some of them are specialized in one. And what they do is they tend to collect information from the environment, take a decision, and act on it, right? And they allow to automate things, allow for monitoring, data collection so we can advance on things. In IoT, we tend to separate the type of IoT based on the use case and the technologies involved. For example, we have a consumer IoT where you would have use cases like your smart watches, fitness, smart home, smart plugs, and whatnot. Automotive is actually a very interesting category because all the cars are getting connected right now. If you take a look at a Tesla car, it's probably your biggest and most expensive IoT device out there. And yeah, automotive technologies are just really interesting per se. Then we have industrial IoT or IIoT, where we're seeing lots of development there, right? For example, in the smart city area where cities are starting to work on smart lighting, parking, waste management. You have your typical operational technologies, industrial control systems, and SCADA, which are just production environments. Maybe you have a smart grid, which has evolved a lot over time. So in times of IoT, there's like many devices getting connected. It doesn't matter what sources you look at. The graph tends to look like this one here. So it tends to go into a geometric curve, and or an exponential curve, and it just keeps on growing. So, and everything's getting online, right? There's so many IoT devices. Even, for example, we found an Alexa controlled toilet. So you can just rule out, Alexa, flush the toilet. If you want to find things like these, you can just pick up this internet account, this Twitter account, Internet of Shit. It's really fun. It's interesting. If you're bored, you'll find something that will make your day on their feed. So IoT is complex because we're dealing with different layers that have to work all together. On one of the layers, we have the devices, the sensors, and the things, which are actually made of hardware, software, or firmware, which is what it's called when it's the small software that's running on top of these devices, this embedded software. You have communication protocols. Sometimes you have gateways that are translating different technologies or routing messages back and forth. You have your network technologies on which these things are built on, right? Which are actually a lot of them. You have a data collection layer where all information from the sensors and the things is going to be going to be able to take decisions, right? Which are taken in the next layer, right? Where you normally tend to have a visualization layer or something that does the business and your different applications that are working on that. Another way to break this down is based on the technologies they use, right? So you have all your hardware where you have systems on chips, microcontroller units or MCUs, sensors, actors. You're going to have your device firmware, which could be a bare bones firmware, which is only dedicated to use for that device, especially slimmed down. Or maybe you have something that's based on Linux that would probably fit into your bigger devices. And then they just have a daemon or a process running in that Linux, embedded Linux. You have all your connectivity where you're going to find things like an IP layer, maybe Wi-Fi, Bluetooth, Zigbee, Z-Wave, custom protocols. You're going to have your mobile applications, which tend to be the trendy and the easiest interfaces for most of these IoT devices. You're going to have web applications, which are going to give you your backends to your web applications, so you can control your devices and maybe have a single pane of glass to see all your dashboards. And you're probably going to have IPAs and backends that are going to be enabling everything to work together. From the security point of view, you actually have to deal with all the complexity of all these different layers, all the interactions, and all the weaknesses present in all of them to actually make a device secure or make an ecosystem secure. And with that, we're going to jump into IoT security. There's a running joke on the internet, it's been there for a long time, that the S in IoT stands for security. Which normally tends to mean that there's lots of devices out there that are not secure, which we tend to agree that is actually sad but true. Most of the IoT devices we picked up out there have not been secured. One of the main reasons for that is that they have a quick time to market, so pressure to get the devices out of the door very fast, and they're pushing for low costs, right? Especially in the consumer IoT area. And if you're doing things fast and without spending much money, you're not leaving much space for security. Security takes time and it costs money because you need to pay for good professionals to do it and to do a detailed work. Lots of the marketplaces and platforms and ecosystems out there are not secure. In many cases because they don't have security requirements in place, to ask for anybody who's getting into these ecosystems that have to comply with them, or actually, and there's no regulatory compliance in many states yet. So we assume that maybe next year or the year after that, there's going to be more laws requiring IoT devices to be more secure, but we're just not that far there yet. In many cases, platform providers and end users are actually carrying the cost of security, because if a big, let's say a big mobile provider, they have if someone gets hacked on their devices they sell you, they're going to suffer a reputation damage, and since they don't want to do that, they are contracting people like us to actually do the test for them instead of the vendors designing and delivering a secure product. And the end users pay for the attacks with their data, or hopefully only their data and not something physically happening in their homes and their environments. So, current status of IoT summed up. Consumer IoT devices, they tend to be cheap, with a quick time to market, and somewhere along the way they turn into disposable devices. And when you buy them, you have no idea how long you're going to be supported. In the industrial IoT or in enterprise IoT, we're going to see lots of binary and proprietary protocols in place, which actually happens because of how these things have evolved, especially when you talk about old technology or actually operational technologies, where these things were developed, with serial lines that went all the way into there. So the only way to interact with these devices was to get on the shop floor, connect to them, having the right engineering tools to be able to understand what the hell was going on. And now they just slapped on IP connection to that, and they started integrating it and making it easier, for remote login or people to work from home or whatnot. In most cases, they base their security on false premises, right? For example, they just say, oh, we're just transmitting sensor data. We don't need to secure that. Or maybe we're just using network technology X, which is secure, but they forget to actually use these security features. Or, the biggest lies. If all of our communications happen behind our firewalls, it means we're just secure. Now, we know how that ends up. One of the things we've seen is that we're actually, as an industry, we're recycling the IoT industry, recycling bugs and errors from the past. It's like going back to the 90s, where we had clear text protocols, where we would use Telnet instead of SSH, because SSH didn't exist, where we had big problems with authentication and trust management, right? For example, we use SSL, but you don't validate your certificates, or we just have non-mature stacks because they're just new. And these are things that we should have learned of already as an industry, right? As an IT industry, or what about? And people should learn things in universities, and it should be part of our daily lives. So why don't we just make the devices secure by design? Well, this is actually the best way to do it. It's the most effective way if you take it from the design all the way to implementation and make it security part of your life cycle. There are studies that can say you can actually save up to 20 times the investment instead of bolting it on at the end. So if my devices are already out there, you already have a product, I have bad news for you. There's no easy way to just bolt security onto it. In most cases, this will actually take a couple of releases until you get that far where you have a more secure device. And you have this, and there's no silver bullets. So how do we do this? Since the rabbit is already out of the hat. There's one, you could just go ahead and do a risk-based approach and do your full analysis. This will take a little bit of time, right? And you would go ahead and do a complete security assessment where you define your attack surface. You go ahead and do your threat modeling, maybe do your pen testing, and then you have to fix issues, right? And here's when you're gonna have to, where the OWASP IoT can come in handy, because you can use the OWASP IoT Top 10 to use it as, as input for your threat modeling to see if you're covering those big risks, or it's actually you can use that to help you prioritize, because you want to make sure that you fix the things that you can fix quickly and have the biggest impact. Once you've done that, you can do a little dance. All right, so let's go into a little more details. First of all, with the attack surface, we normally tend to split it into 4 categories, mainly, or 4 buckets, mainly because of the know-how and the experience you need to work with them, right? So anything that has to do with the devices and the hardware goes into one bucket. Normally, you have vulnerabilities that are based on the firmware and the software that's running on these devices. Then you have mobile web infrastructure and networking security issues, which would be your classical IT security. And then you're going to have radio communication, because you're using different radio protocols in your devices. So what you want to do is you got to start with your threat analysis. You want to make sure you have a big picture. You create a design diagram where you include all of the components, all the interactions between them. Then you pick up your favorite methodology. For example, you want to use Stride or BSMaaS, and then go through each of the interactions and see if you can spoof them, if you have integrity and whatnot. then you're going to have to fix these issues, right? And one of the hard things is to define your priorities. A common approach here would be to go for the quick wins first. So let's take, for example, the Jeep hack, right? Happened a couple of years ago. These guys, they prepared to talk for DEF CON and they hacked the Jeep and they took it out of the road, turned off the motor, radio, the whole, they did the whole deal remotely, just sitting in their sofas, after taking apart a couple of cars and training for this. It was not easy, right? And the quick win is asking for their mobile provider to enable client isolation, right? Which basically cleaned out the attack surface, the remote attack surface, because with that, none of the different cars can be spoken to from other SIM cards. And this was actually the best thing they could have done. They should have done that from the start. And then you can go with a bit high impact issues, for example, taking anything from your OWASP IoT. Another way, which is a shortcut, is that you can just test and review your OWASP IoT top 10. Big disclaimer here, this does not replace your security process. The process I described before is actually the correct way of doing it, but this is a shortcut that will, it's better than, it's better to do this first quickly and then go with the details than not doing anything at all, right? So, I've already named this before, the OWASP IoT project. Basically, the idea of the project is to help manufacturers, developers, and consumers understand the security issues in these things. So, what is our top 10 list? The first of all, weak guessable password or hard-coded passwords in there. You have insecure network services, insecure ecosystem interfaces. So basically, if someone can hack the web interface or the APIs. This is actually pretty big and lots of devices forget it. You need a secure mechanism to update the devices that have gone out of your shop floor, right? Using insecure outdating components, which is actually, hopefully you have a secure update mechanism so you can patch and update the components you have in there. Insufficient privacy protection, not storing data, transferring and storing data in a secure way. Basically, encrypted in motion and in rest. You don't have lacking a device management. Insecure default settings and lack of physical hardening. So, let's go into a couple of use cases to see this in place. So, word of caution, these use cases that I'm going to be working with are generic use cases. I'm not going to be talking a specific device. This is actually like a collection of our experience with these types of use cases, okay? So, we have a device that has a GPS, it has Wi-Fi, Bluetooth, and GSM, right? So it can track anything anywhere, and it uses GPS for fine grain, and you can use Wi-Fi and Bluetooth for the last mile. If you want to find something in the last 10 feet or 10 meters, a Bluetooth beacon will actually help you with that, right? And your device is connected via GSM with the cloud. You have a mobile app that talks HTTPS with the REST API, and yeah, your mobile app can talk Wi-Fi and use Wi-Fi and Bluetooth to figure out how this tracker works. So what are the typical things you would find on your mobile app? Yeah, take a look at the OWASP IoT top 10 for mobile, right? You will find lots of mobile apps that do not check their certificates. There's no certificate validation. So anyone can do a man-in-the-middle attack. Or maybe they're not doing certificate pinning. Dictionary attacks on the mobile app that allows you to crack it open. Problems with authentication, business logic. Hard-coded password information. So sometimes you can find the API keys that are hard-coded into the app. And of course, using insecure third-party libraries. And of course, in many mobile applications, you will find lots of trackers. You will find, your typical crash analytics and stuff like that to figure out, so that the developers know what the errors are coming up. You're going to find tracking for the marketing people. So there tends to be lots of trackers, and they are pushing that information out. Which, for the privacy point of view, this is not good. You have to make sure especially in times of GDPR, you want to make sure that you have that under control. Web portals, they tend to have insecure SSL setup. They have problems with authentication and authorization. So for example, dictionary attacks. Um, Injection flaws are your typical cross-site scripting, or maybe and often using insecure and third-party libraries. These tend to be JavaScript. So there's too many people using old versions of jQuery in their devices. Please, please, please use an updated version. So on the cloud side, there's insecure API communications because people assume that nobody's going to try to attack their API. Improper protection of resources. You will have things like, for example, the ability to modify data, right? So for example, you could use if you pick up one device and sniff the communication with the cloud service, you can find a way to change the configuration of a different device. And of course, the typical S3 buckets, or basically you're storing information in the cloud, and they're open for anybody to look at them. Device and firmware. These findings actually are a lot more fun. Maybe they have the smallest impact. The biggest impact is always going to be in your central components. They are going to be in your backends and your mobile apps. Actually, mainly in their backends, because if you do manage to do something there, it will affect all users. But these are the most fun, right? So if you crack open a device and take a look at it, you will find maybe debugging interfaces here. Please do not pay attention to my soldering. That is not my best handiwork. But anyway, you can solder up on some cables on this, and then you can connect to these things using maybe for example, something like a JTAG layer to connect to JTAG or serial connections. If you find chips and flash chips on there, you can actually connect directly to them and dump the contents of these things. Often there's no integrity and signature verification of the firmware. That means I can upload any firmware I want onto the device. Insecure over-the-air update mechanisms, and plain text traffic going out of the device. So, summing this up for consumer IoT, most of them are not secured by design or implementation. They are riddled with OWASP top 10s in the mobile web APIs in IoT. Like I said, the biggest issues are in your backends and your APIs, because it will affect all of the customers and not just one user. Normally, if the device is already out the doors, it takes somewhere between 4 iterations to pass a security test, which in time is somewhere between 6 to 9 months. And if it's a startup, they will be CAS stripped, and this is actually not good for them. We've seen lots of companies go tits up because they were, their plan was to sell this to big companies and they couldn't do it. Okay, let's talk about smart city and irrigation system. So this setup is a little more fun. We have devices that are sensors and actors. In this case, we actually have, So we have something that is a sensor that's checking the moisture of the soil to see if, do the plants need water, yes or no? When it detects that, you have another actor which actually opens up the hose and, waters the plant. They are going to be talking Zigbee because it's lightweight and it's trendy, and it's actually a pretty secure protocol. They have a gateway that allows to extend communication. So this gateway is going to be talking Wi-Fi, or maybe has a LAN cable connected to it from inside the building, and it's taking care of the garden that's outside. In the back end, you're going to have an MQTT queue. You're going to have a REST API for the mobile application. And then you're going to have, maybe you're going to have a direct web interface to control everything and have your analytics. So, if you go through the wireless, things that happens often with Zigbee. Did you enable the encryption? Are you doing key management, or is just one key for all time? MQTT is a clear text protocol by design. Actually, it's a binary protocol, but it's not encrypted by design. So you want to make sure you want to run this over SSL, or in SSL, or in VPNs, right? To make sure that you have a secure network communication. The next thing you want to make sure is that you're doing correct authentication and authorization, and you want to make sure that anybody is only allowed to talk to the queue that they need to. For example, you want to make sure that no device can change the configuration of another device, or no device can actually write values for another device. So for example, you want to make sure that nobody comes in and by faking this sensor, they can make make sure that they don't want to make everything water be flowing all the time. So on these devices, you will find, or often you will find that these devices are, maybe they're a Raspberry Pi or something similar, and all their configuration is stored on an SD card, which is actually easy, makes it easier to, upgrade and distribute firmwares, but it means that anybody can go up and pull out that SD card, and if it's not encrypted, they can just go ahead and read the configuration and, for example, extract the credentials of the device. You will often find the serial interfaces. So you just connect the right cables, enter, and have the right speeds, enter, and you have a root shell on these devices. Or maybe they have a debugging interface, so you can go ahead with JTAG and dump the firmware, or see debug exactly what's going on in memory to bypass, for example, authentication. You can go ahead and dump sensitive information from the chips. You have insecure verification or insecure update mechanisms, and then very often you have plain text traffic going out of the device. On the cloud APIs, just like I said before, make sure you take a look at the in communications and things like that. On the mobile apps and the web portals, these are known. So one thing that happens in many cases on these devices is that they're not doing encryption because you want to keep your battery life longer, and anybody can just go ahead and fake any of your devices. So if maybe you don't need encryption, but signing them and make sure that nobody can fake messages is really important for you. So to sum up, in our smart cities, you have a large diversity of devices that may be going from Arduino project with shields on top to complex boards with custom firmware, depending on how mature the company is that's doing these, right? Lots of the time, main issues are insecure messaging queues and APIs, authentication, lack of backend or API security, and no authentication or encryption on their wireless devices. And the main justification here is that we're just transmitting sensor data, right? Which makes it non-accessible. Sensors in a parking garage, if someone fakes them all and tells that the car garage is full and nobody can come in for a couple of days, it's just sensor data, but it will be very expensive. So that's all I have for you for now. I'm going to be on the Slack channel if you have any questions. Here's my contact data, so feel free to reach out. And hope you enjoy the rest of the BSides conference. See you guys around.